interference, and when both the waves are meet, crest of the one wave is meeting trough of the another wave. At that point, what happens? There is destructive interference happens, and we are getting the black color of the line. So this we are seen yesterday. All these points I had explained yesterday. Now thin films. Thin films, light rays incident on a thin transparent film undergo reflection from the upper and lower surfaces of the thin films or travel along different path, which may be reunited to produce interference pattern. तो interference pattern किसकी वजह से मिलता है? यहाँ पे सोप बबल में हमने देखा. This floppy disk is also one of the example of the these thin films. We are using thin films in this floppy disk so that data is stored in the floppy disk. So there is thin film is used on the plastic. So this is also one of the example of the thin films. When thickness of the film is 1 wavelength of visible light, it is around 5500 angstrom. The thickness of the film is between the 10 to 50 micrometer. It is called as the thick films. Next point is the path difference. Path difference क्या होता है? It is the difference in distance traveled by two waves from their respective sources to give a point on the pattern. This is the source of light having waves S1. This is another source S2 having wave coming out of it, and when both the waves are meeting here, what happens? There is constructive interference happens, and we get the light here, which is having much more or higher intensity. And in this figure, this is S1 and S2. When both are meeting at this point P, there is destructive interference happens. It means crest of the one wave meeting the trough of the another wave. So that's why we are not able to get the light here. We are getting the black spot or black line. So the path difference in destructive interference is lambda by 2. The path difference in case of constructive interference is 0 or lambda. The path difference between the two waves of wavelength lambda is given by delta is equal to n into lambda, where n is equal to 0, 1, 2, 3. Wavelength, what is meant by wavelength? The distance between successive crests of the wave. So this is the wave. So the distance between crest of the one this point to this point. यहाँ से एक वेव स्टार्ट हो रही है, यहाँ पे खत्म हो रही है. So this wave just starting from this point and it's ended at this point. And from this point another wave is started and this is another wave. So the distance between crest of the one wave, this distance, it is called as the wavelength. Similarly, the distance between the trough, this is the trough of the one wave, this is the trough of the another wave. So the distance between trough of the both the wave is also called as the wavelength, which is represented by the lambda. This is symbol of the wavelength. So the path difference of lambda by 2, there is complete destructive interference happens. यहाँ पे मैंने बताया, if the path difference is lambda by 2, then you will get the destructive interference. If the path difference is lambda, then you will get the constructive interference. Now the next point is phase difference. What is phase difference? The time difference between these same positions within the wave cycle of two waves is called as the phase difference. So this is the one wave, that is S1. So this is the point at which this wave is starting. This is one wave, and this is another wave having amplitude, and there is some difference. It means the distance between crest of the one wave and the crest of the another wave. तो ये जो distance है इसको क्या बोलते हैं? This is the phase difference. So the phase difference is the time difference between the same position. Same position means this one. If I consider this is the one position and this is another position, the time difference between the same position within the wave cycle of two waves is called as the phase difference. तो इसे क्या बोला है? Phase difference बोला है. Production of the colors in thin films. When a thin film is exposed to white light, it shows colors in reflected system. Light is reflected from top and bottom surfaces of thin films, and reflected rays interfere with each other. And the path difference depends on the thickness of the film and angle of refraction. So path difference किस पे depend है? The path difference depends on the thickness of the film. How much is the how thick that thin film is, and the angle of refraction. इसके ऊपर वो रहता है. Next point is the Snell's law. What is Snell's law? The ratio of sine of the angle of the incident. So this is the ray incident on this film. So this is the angle of incident I. It is the light coming in the rarer medium, and mu1 is the refractive index of the rarer medium, and mu2 is the refractive index of the denser medium. So what happens here? The velocity of light found to be decreases. When light is going from rarer medium to the denser medium, the velocity of light to be found to be decreases. And it is given by mu1 sine of I is equal to mu2 sine of R. So the sine of I upon sine of R is equal to mu2 upon mu1. But mu1 and mu2 are constant. So I can write mu1 is equal to mu2 is equal to mu. So mu is equal to sine of I upon sine of R. So this is the equation of the this is the representation of the Snell's law. So the refractive index is the measure of reduction in the velocity of light in the medium that effects result from the interaction of light with the material. So refractive index क्या है? It is measure of reduction in velocity. यानी कितना how much the velocity of light found to be decreased when it is going from rarer medium to denser medium. उसको क्या बोलते हैं? Refractive index बोलते हैं. Next point, in optics the refractive index is also called as refraction index or index of refraction of a material in dimensionless number. So this mu is dimensionless. There is no any dimension of mu. That describe how fast the light travels through the material. How much fast that light is travel, that is showing by the refractive index. N is equal to C upon mu, that is the C is the speed of light in vacuum, and V is the phase velocity. Phase velocity of light in the medium. In case of water, the refractive index is 1.333, and for other material it is different. So material to material refractive index is changing. It depends on the thickness as well as material. Next point is the derivation of interference of thin films with uniform thickness. So this is very important article. So there in the exam you will ask question on this topic. So you have to draw the figure and explain mathematically all these points. So what type of questions asked in the exam? You just write down one question on this topic. Hello, students?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so you write down the question, what type of questions asked in the exam. So mostly questions comes on this topic, that is the interference of light in case of thin films, as well as show the constructive and destructive interference conditions. So write down question. Derive the expression for path difference everybody is writing.
Yes, sir.
Yes, sir.
Yes,
So
sir.
you write down this one. Derive the expression for the path difference in reflected light. The path difference in reflected light, and derive the condition for constructive and destructive interference.
Sir, can you repeat, sir?
I am repeating. Derive the expression for path difference in reflected light and derive the conditions for. कंडीशंस आपको डिराइव करना है. डिराइव द कंडीशंस फॉर कंस्ट्रक्टिव एंड डिस्ट्रक्टिव इंटरफेरेंस for a film of uniform thickness. For a film of uniform thickness. So you have to draw this figure every time and derive the expression. Let's consider a ray AB is incident on this thin film. This is the thin film. This line is upper portion of this thin film, and this line showing the lower portion of the thin film. So when light is incident, that is, it is coming from rarer medium to denser medium, what happens? The velocity of light is changing. Here transmission of ray happens. Then light is transmitted from B to C. At point C, what happens? There is some refraction happens, and also reflection happens. So the reflection and refraction happens at point C. Again, when light comes at point D, means CD, when light comes from point C to D, there is again some part of light is get reflected and some part of light get refracted. So we are getting two rays, R1 and R2, coming from the thin film. The light is incident on the thin film, that is single one, but we are getting two rays from the thin films. When these two rays are interfere with each other, what happens? There is interference happens, and we get the different colors of light. Okay. So the medium is air above the thin films. Medium is denser in the thin films, and at the last it is again air. So at point E, there is again refraction happens when light is coming from light rays coming from point D to E. At point D, some amount of light get reflected, some amount of light get refracted. So the same expression I had written here is the light incident here. At point B, some amount of light is get transmitted, some amount of light is get reflected. So the interference is due to light BF and DG. तो इंटरफेरेंस का किसकी वजह से हो रहा है? The interference happens because of the light BF and DG. The distance traveled by DH in air is equal to mu into BC plus CD. तो यहाँ पे आप देख रहे हैं कि when light is incident on B, so ray immediately get reflected, but there is path difference is here. The light DH is coming sometimes later than BF. So there is some difference in the time of reflection of light BF and DH. So that is nothing but the path difference. So there is a path difference between both the rays R1 and R2. If we say the BF is the ray R1 and DH is the ray R2, so there is some path difference between both the rays from the point of reflection. So the distance traveled by DH in air is equal to mu into BC plus CD. Mu is the refractive index of the material and BC plus CD. Okay. And the path difference between the two rays is equal to delta is equal to mu into BC plus CD minus BG. So what I will do, I will put a line from point D to BF, and I got the point G here. Capital G is the point of point because of the line drawn from the point D to G. So I got this point here. So I write this as a delta is equal to mu into BC plus CD minus BG. My BC plus CD minus BG. Okay, this is your equation number 1. Now consider triangle BCK. If you see this triangle, K is the point it is the midpoint between the B and D. So I got the two triangles BCK and CDK. These two triangles I got. If you see that both the triangles are equilateral triangles, means both are equal. So that's why both the triangles are congruent. So the BC is equal to, this is BC, BC is equal to CD. Since both the triangles are equal, so that's why BC and CD both are equal. So that's why BC is equal to CD is equal to क्या होता है CK upon cos of R. BC is equal to CK. CK is what? This is this line. This line CK upon cos of R. Cos of R means this one, angle of refraction. That is small r. Cos of R is equal to CK upon PC. Cos of R is equal to CK upon BC. Okay. But what is CK? CK is common for both the triangles. For both the triangles, CK is common, and CK is nothing but the thickness. So instead of CK, I write the thickness small t upon cos of R. So this is your equation number 2. यहाँ तक समझ में आ गया सबको? हेलो?
Yes, sir.
I will repeat this.
sir.
Tomorrow also we will take this because this is a very important topic. In case of triangle BDG, so this is upper triangle. This is a triangle above the thin pins. So triangle BDG we are considering right now. In case of triangle BDG, sin of I is equal to BG upon DD. So this is I. This is I. So sin of I is equal to BG, means this one, this line, BG upon BD, and a सामने वाली line divided by hypotenuse. So sin of I is equal to BG upon BD. So I write BD is equal to what? The distance between B and D, and K is in the middle. So the both the distance are equal. So BK is equal to KD. Okay. BD is equal to BK plus DK, and both, since both are equal, so I can write 2 times BK. Then tan of R is equal to, it means this one, this point. Tan of R is equal to BK upon CK. Tan of R, this point, this angle, tan of R is equal to BK upon CK. Means this is BK upon CK means tan of R. So I can write BK is equal to CK into tan of R. ये CK यहाँ पे जाएगा तो CK into tan of. But what is CK here? CK is the thickness T. So this CK is the thickness small t. That is the thickness of the thin films. So I can write BK as BK is equal to small t into tan of R. But both are equal. BK and KD both are equal. So I can write BD as 2 times. So I can write BD as 2 times T into tan of R. From equation number 3, this one, sin of I is equal to BG upon BD. From equation number 3, what is BG? BG is equal to BD into sin of theta, sin of I. And put the value of this BD that derived right now. What is BD? 2 times T into tan of R into sin of I. And what is tan of R? Tan of R is equal to sin of R upon cos of R. Put that value of tan of R. Also by the equation of Snell's law, mu is equal to sin of I upon sin of R. But what is sin of I is equal to? I write this sin of R here. So sin of I is equal to mu times, mu is the refractive index, sin of R is the refraction angle. Then so the BG is equal to 2 times T into sin of I upon sin of R into mu into sin of R. So this sin of I just replace with this sin of this mu into sin of R here. So mu into sin of R यहाँ पे मैंने sin की जगह sin of I की जगह लिखा है. Then I got sin square of R upon. Then I got the BG is equal to 2 times mu into T into sin square R upon cos of R. So this is the equation number 4 I got. Put the value, put equation number 2 and 4 in equation number 1. So this is your equation number 4. That is BG is equal to 2 times mu into T into sin square R upon cos of R. ये मैं कहाँ पे put कर रहा हूँ? In equation number 1. This equation number 2. This is equation number 2 and this is equation number 1. Put the value of 4 and 2 in the equation number 1. What is equation number 1? Equation number 1 is the path difference between two rays. Delta is equal to mu into BC plus CD minus BG. Put both the equation here. Then what equation I got? Delta, that is path difference, is equal to 2 times mu T upon cos of R minus 2 times mu T into sin square R upon cos of R. I take common terms, I remove from the bracket. Then what I got? 2 times mu T upon cos of R into 1 minus sin square of R. But what is 1 minus sin square of R is equal to cos square of R. So the total, so the last equation I got, that is the path difference is equal to 2 times mu T into cos of R plus or minus lambda by 2. So this is your equation number 5. So in the exam you will ask to derive the equation of this path difference, and also the sometimes problems are comes on this equation. कभी आपको path difference देते हैं, you need to find out path difference. or otherwise you need to find the thickness of the thin films. Refractive index आपको देते हैं, so you have to derive the, you need to find either the path difference or thickness from this equation. So this is very important equation. Most of the times questions comes on this topic. Now we will see the constructive interference. Constructive interference is given by delta is equal to n lambda. But what is delta? Delta is equal to this one, 2 times mu t into cos of r plus minus lambda by 2 is equal to n into lambda. Lambda is the wavelength of light, mu is the refractive index, t is the thickness. So I can write this lambda by 2 on the right hand side. Then I got the equation 2 times mu t into cos of r is equal to 2n plus minus 1 into lambda by 2. This is equation number 6. So this is the condition for which I got the constructive interference. If the value of n is equal to 0, 1, 2. If it is positive, it means 2n plus 1 into lambda by 2 is positive. Then I got the value of n is equal to 0, 1, 2. If 2n minus it is 1, it is minus 2n minus 1 into lambda by 2. Then at that condition I have taken the n is equal to 1, 2, 3. Destructive interference. So destructive interference delta is equal to 2n plus or minus plus minus 1 into lambda by 2. Put the value of the path difference here, 2 times mu t cos of r plus minus lambda by 2. So at the end, after simplification of this equation, at the end I got this equation, that is 2 mu t into cos of r is equal to n lambda. So this is the condition for the destructive interference. So the maxima and minima depends on the thickness of small t and angle of refraction or angle of incidence of light in case of thin films. समझ में आ गया यहाँ तक?